string, and it will carry round this loop, subtracting one at a time, until it's done it 4 times. So let's look at that, how it works in practice. Well, first of all, we input the word into word string. There it is, Adam. We then take from position 4 one character and place it into backward string. We then go round the loop again to next place, subtract 1, so place becomes 3, and we end up here on A. And we take the third character, puts it again, adds it on to what's already in backward string. It will then subtract 1 again, take the second character, add it on to what's already in backward string, and finally the last character, and add it on to what's already in backward string. So we've created the word in backward string, which is our original word backwards. And all we have to do is to test whether that word is the same as that. And there is an instruction. If backwards equals word string, then print word string is a palindrome, else print word string is not a palindrome. So let's run it. It's asking me for the input. I'll put in Adam, the same words we had before. Adam is not a palindrome, which we know. So let's run it again. Try another one that we know is a palindrome, madam. Madam is a palindrome. Fine. Let's run it again. And this time we'll put in a rather intriguing little palindrome. Madam, I'm Adam. Now, we might imagine that that is a palindrome. In fact, it looks like a palindrome to me. But to the computer, it says, Madam, I'm Adam is not a palindrome. And that's simply because it treats strings of variables, whether it's a space or an apostrophe, exactly the same as an M and an A. And if you look at that very carefully, including the spaces, it clearly isn't the same backwards as it is reading it forwards. Well, you might like to write a little program yourself that ignores the spaces and punctuation marks. Well, it's just a bit of fun was that program, but handling strings of characters is one of the most useful things that a computer can do. And it's the key to word processing. And we set up our machine here as a word processor, and by that we've put in a word processing package in the machine. In this case, it's stored on a chip inside the machine. We could have stored it on disks or even on cassettes. The extra piece of equipment got to our normal layout, of course, is a printer on which we're going to print out our letters. So let's load the letter in, and load it in from disk, and there it is on the screen. Of course, this is only an example. It's only a rough idea of what a letter, but it gives us some idea of the sort of things that any word processing package would do. Well, first of all, we want to put in the real name here. So we position the cursor itself, that's the flashing line, using the cursor keys, over where we want to start typing. Dear, and we'll call it to Mr. Briggs. That's that. There's a spelling mistake down here. There is R-H-E, and to correct that we can again overtype it and simply type a T. And we've got equipment here and equipment here and equipment there. In fact, I'm writing a letter about a printer, so I might like to replace the word equipment with the word printer. And all I do is type replace equipment with the word printer. I'm such a bad typist that I think a word processor is absolutely brilliant for me. Replace. There it is. And this will position a new cursor over the equipment, and we say, yes, we want to replace that by printer. The second one, yes, we'll replace that. The third one, no. And the last one, yes, we'll replace it with printer. So what else do we want to do? Well, we're writing about a printer. We have a brochure, so perhaps we want to add something to that paragraph there. And we, again, can add something. And I will say the printer contains several advanced features, and I am sending you a brochure. That's fine. And look at it again. Well, I still don't like it completely. I'd like to move the whole of that paragraph up here in this space here, so my brochure comes at the end. And to do that, we simply position a marker at the beginning of it, and then move the cursor to the end of the paragraph, position another marker there, and then move the cursor to where we'd like it to be sent, and move the paragraph, and instantly it's moved around. Well, that looks pretty good, but I don't like the look of this right-hand margin. It'd be quite nice to straighten all that up. So I can take the cursor to the top of the screen, and there's a special key here. I can just bring the cursor down, and paragraph by paragraph, it will straighten them all out. And there it is. So what I want to do now is to save that, and I'll save it, I'll call it letter 2. And that will save it on disks. And then finally, to have a look at it and send it off, I'll print it out. Print letter 2. There it goes. Well, this is the sort of quality printer you'd need for writing letters. But the other important use of a printer is when you're writing a program, and you can get away with something a bit less expensive. Well, this Sinclair machine has a small printer on it, and we've written a sort of version of our palindrome program, and we could print that out. And there it goes. Well, so far, we've only been looking at the principles of writing short programs. But when you write longer programs, not only is a printer almost essential, but there are some new techniques to be learned. Going shopping in a familiar environment like a supermarket seems very easy, compared with writing a long, complex computer program. The outline is very straightforward. You write out a shopping list, you go to the supermarket, you select the goods that you've got on your list, you pay for them, you go out and you go home. But imagine writing a program for a computer-controlled robot to do exactly the same thing. The actual actions that you go through within the store would have to be broken down into very, very carefully defined procedures, and the robot would have to know exactly what steps to do things that you, in your shopping trip, take for granted. But one of the procedures that we all use is what I call the best buy procedure. And you can use it for buying, for example, toothpaste. Some people buy toothpaste because they like the flavour, but I buy price per unit volume. So I simply take the toothpaste, look at the price, look at the volume, so many millilitres, divide the price by the volume, select the next one, divide the price by the volume. If that is cheaper than that, then I select this one. But that procedure isn't only useful for toothpaste. It can be used for almost anything that you buy by weight or by volume. But there are a couple of other procedures we take for granted. First of all, there's the counting one. I want to buy 3 avocados, so it's 4. Avocados 1 to 3, select avocado, place in basket, that's 1. Next avocado, select avocado, place in basket, that's 2. Next avocado, select avocado, place in basket, that's 3. And we've got 3 avocados. But it's not every time we want to do it by counting. Sometimes we want to buy by weight. And there we want to buy a pound of tomatoes. So we have an instruction which says, repeat, place tomato on scale until scale greater than 1 pound. So we keep on repeating until scale greater than 1 pound. And there we have just over 1 pound of tomatoes. Well, those are fairly straightforward procedures, but there's one procedure which, even in a supermarket, is very complex, and that's at the checkout. Well, this is one situation we've all been faced with: how to get out of here in the shortest possible